Hello everyone, today we will discuss the topic about through the loops. Introduction to loop. Looping in C++ is a means to repeat a series of statements based on the provided condition. One pass in the loop is called an iteration. Usually, a looping statement undergoes several iterations. Basis of a looping statement. Like any other statements of a programming language, looping is also composed of several components. These components build up the basis that a looping statement needs to undergo internally. There are 4 phases of any looping statements in any programming language. These are initialization, condition, body, increment, decrement. Initialization. Initialization is the phase in looping statements where a variable called counter is set an initial value. Note that declaration of the counter can occur outside of the looping statement, hence there is no need to prioritize declaration as part of the first phase. The counter manages the flow of the loop. Usually, each iteration relies on the value of the counter. A typical initialization of a counter is set to 0. However, there are cases wherein the counter is initialized with the actual number of iterations needed for the loop. This setup is upon the discretion of the developer or as needed in the identified solution. Condition. Condition is the phase in looping statements where an expression is evaluated which dictates whether the loop should stop or continue. The counter is usually the basis of this phase. However, that is not always the case. The condition always occurs within the parentheses of the loop. Body. Body is the phase in looping statements where the statements inside the loop are executed. These are simply the statements within the code block of the looping statement. The states in the statements within the body differ depending on the discretion of the developer. And lastly, the increment-decrement. Increment-decrement phase in the looping statements is where the counter is increment or decremented. Increment means a variable is added by a certain constant. Decrement, the counter of increment means a variable is subtracted by a certain constant. This constant is typically 1. Depending on the chosen looping statement, the increment-decrement can occur within the body. Looping statements in C++. C++ is armed with 3 distinct looping statements which differ mainly on how the condition is evaluated and when the condition is evaluated. The looping statements in C++ are while loop, for loop, do while loop. Okay. While loop. While loop is a looping statement in C++ where the condition is evaluated right before the body is executed. The initialization phase does not occur within the looping statements or the parentheses of the statement. The increment-decrement happens at the end of the body. This is the example of a program while loop. For loop. For loop is the looping statement in C++ where the initialization, condition, and increment-decrement phases occur within the parentheses of the statement. Only the body is separated from the actual for statement. Compared to while statements, for statements is range-based. This means that the counter is essentially the blood and life of these looping statements. Here is a program that displays an equilateral triangle with the height depending on the user's input. we use the int main to start, or what we call our entry point. Now in the next line, we have int to declare integers. The objective of this is to input numbers. In this line, we use the cout to display an output string in order to inform the user that you need the number of rows to be entered. Next, we use the scene to store the user's input in the variable of the end. In this line, we use the cout end line to create a new line. Since we need to display a triangle with a height depending on user's input, the conditions for the for loop is I less than the user input. The first inner for loop will display the necessary places to form a triangle. The condition being that current row should be more spaces in the beginning of the triangle at the peak, and gradually decreasing as we go to the bottom of the triangle. Therefore, we came up with the equation of n being the user input minus I being the current row minus 1. The second for loop will create the foundation of our triangle. Take note that every increment of iteration, the number of star doubles depending on the current row with an extra one of 1 star. That is why we came up with the formula of I being the current row multiplied by 2 with their product added by 1. The last line of our outer for loop ends with an end line to signify that we have ended the current row. Do-while statements. Do-while statements, the last looping statement in C++ is the do-while statement. The do-while statement is closely similar to the while statement. They only differ when the condition is evaluated and when the body is executed. This is the example of do-while statements. Controlling loops. When dealing with the looping statements, everything has been linear and straightforward. However, this is not always the case when we implement our solutions. In C++, we have two controlling statements which can change the flow of loops at any part of the iteration. These are the break and continue statements. The break statements terminate the execution of the entire loop that it is in case. This is placed anywhere within the body of the loop. Any statements found after the break statement, should the break statement be executed, will not be executed. The continue statement. The continue statement terminates the execution of the current iteration. What it does is force the loop to skip the rest of the statements and proceed to the condition evaluation right away. Our next topic is about the dimensions of data types. Variables in dimension. The first dimension. When the computer learns that a variable was declared, it allocates several spaces in the RAM for the declared variables. The number of spaces that will be allocated will depend on the data type of the variable. For the data type int, 32 bits, short 16 bits, long 64 bits, bool 1 bit, float 32 bits, double 64 bits, char 8 bits. If we follow the allocated sizes per data type, in for example, the computer will allocate 32 bits of space for one integer variable. Those bits are located adjacent to each other. Think of it as a train. One car is adjacent to one another as one bit of the 32 bits integers in adjacent to one another, internally speaking. The same thing is applied to characters. One character variable occupies 8 bits of space in the RAM. How about strings? Since we talk about the strings as a series of characters, in this case, a string is an example of an array. A string is a series of characters wherein a string can be composed of two characters in one declaration, such as this: char age 2 is equals to 25. The other dimensions. An array is variable that can contain more than one value of similar data types. Arrays are bounded still by the data type they are declared. For example, if we declare an array of characters, the value that is stored are all characters. Assigning non-characters value in the said array would result to exceptions or errors. An exception is a programming language or developer defined error that is the result in inappropriate actions committed unexpectedly. The syntax of declaring an array is a data type, variable name, size. The data type in the syntax is similar to how we declare variables. It can be int, short, long, or any of the remaining data types. The variable name is our typical alias we give the variable to reference in the future. Lastly, the size is a non-zero integer which dictates the maximum number of values the array can store. In this example of char h2, we are declaring an array of character type that stores up to 2 values characters. Take note that one character is 8 bits in size. Therefore, when the computer recognizes that this array is declared, the computer will allocate 16 bits of size. Similar to our example of the train, think of a variable as one card. Now, in the example, the array of 2 characters are 2 adjacent cards. If we declare char zip code 4, we are declaring a maximum of 4 values for the character. Hence, we have 4 adjacent cards. This analogy is important to recognize the internal workings of the computer. For example, if we declare 2 arrays, char h2, char zip code 4, the computer will allocate 2 separate trains, one with 2 cards and another with 4 cards. As to where exactly in the RAM those 2 arrays would allocated mainly depends on the computer. Up until now, we are talking about one-dimension arrays, but a computer is powerful enough to allow multiple-dimension array. Let us take a 2-dimension array. When we compare one-dimension array to a train, we can think of the 2-dimension array as a table. For example, char matrix 5, 5. Here we have a 5 by 5 array. In relation to a table, we have a table with 5 rows and 5 columns. Similar to the rest of the examples, the said array can only contain character values. A limitation to this is that each row has exactly the same number of columns. Row 0 has 5 columns, row 1 has 5 columns, until row 4, which has 5 columns as well. Notice that I started my counting using the number 0. When we call the first card using the variable name of the array, we use the index 0. An index is an integer reference used to indicate which elements of the array is being accessed. An element is a value of the array. If we call matrix 0, 0, we are calling the first we are calling the first column of the first row. If we call matrix 0, 1, we are calling the second column of the first row. If we call matrix 1, 0, we are calling the first column of the second row. The reason behind this approach of calling the values in an array is because of how the computer interprets the call. For example, remember our train example with a certain number of cards. We call the second card. We use index 1 since we are calling the value 1 element away from the first card. If we use index 2, we are calling the value 2 elements away from the first card. If we use index 0, we are calling the 0 element away from the first card, hence the first card itself. This is the formula of the allocated size of 2D array. Bits of data type times rows of array times columns of array is equals to bits of 2D array. It's still possible to create 3-dimension, 4-dimension arrays, but representing them in the real world application becomes tedious, like 3-dimension array is a cube and a 4-dimension array is like a cube with a factor of time. In addition, creating these kinds of array are computationally expensive and they consume resources, which grows exponentially. Here is a program that's add the given number of the users. The user will choose how many number they will enter. We use the int main to start, or what we call our entry point. For the next 3 lines, we need to ask the user how many numbers he will enter. We use integer to store the numbers to allow the flexibility. Next line, we declare an array of integers wherein the length is equal to the number defined by the user. Next line, we use for loop since we will be working with arrays. We will ask the user for the exact value of elements and store the value to the array. Next, we look through each of the elements of the array and add them to the integer variable sum. Lastly, we display the number of elements and the sum to the user. Here is the other example, the program using array. Okay, our next topic is about introduction to functions procedures. Code block. Code blocks are generally designed to be written inside the int main code block. This way, we look at our code sequentially. That means we never left the int main code block. This is the time to introduce functions. Functions are a separate code block which performs one specific task. This separate code block can accept input from the other code blocks. In addition, they can also return back values which can be a result of the action performed within the function. We are all very familiar with the most famous function in the entire C++, the int main code block. The int main function, as we have mentioned several times throughout the course, is the entry point of any C++ application. It is here where we place the entire logic of our application. Like the name main suggests, it is the main function of the entire C++. Components of functions. A function is composed of several components which are similar to different programming languages. These components build the fundamentals of a function which are necessary to completely differentiate and define the rule of the function from the rest of the other code blocks. Also, these components build up the function's properties and capabilities, which are exploited not only by the developer of the application, but also other developers who use several snippets of the source code. These components are return type, function name, parameters, and body of the function. Return type. The return type is the data type which the function shall return as its final execution. The return type can be any of the defined data types found in table 1. These are the return type: int, short, long, bool, float, double, char, void. Table 1 covers the fundamental data types in C++ with the addition of the void return type. The void return type simply tells the application that the function shall not return any data. Function name. The function name is the alias which will be used as a reference to the function. It is similar to variable names. The only difference is the presence of the parenthesis after the function name. Parameter. The parameter is the component of a function which enumerates the input values of the function. The parameter is placed inside the parenthesis of the function, right after the function name. The syntax for the parameter is data type variable name. A function can support more than one parameter. Should that be the case, the parameter inside the parenthesis are delimited by a comma. Body of the function. The body of the function is the group of statements which the code blocks of the function. Regardless of the design of the function, if the return type is not valid, the last execution statement should be return value, return variable name, or return expression. We have example here of a function that will add two numbers. We start off by defining a variable named sum. Notice that before the name of the function, we have declared the return types, which is integer. Next, the function accepts two values, integer a and b. Now, inside the function, we have a return statements, which add the values of two variables and return that as the result of the functions. Next line is our function, which serves as the entry point of our application. Lastly, we immediately display the sum of two contents. We do this by calling our sum function, which we defined a while ago. The last three lines will simply display a closing remarks and terminate the int main functions. This is the other example of a program using functions. Variation of functions procedures. Function can be arranged depending on the need of it and its function. C++ does not discriminate the use of functions. Hence, any function can be defined any number of times. Void function without parameter. Figure 1 shows a source code where a void function print hello world is defined. Also notice that our defined function is placed before the main function. The reason behind this approach is to let the function to be defined prior it is called. Let us say that the main came before our print hello world function. By the time our print hello function is called inside the main function, our function is yet to be defined. Hence, the main function will throw an exception stating that the print hello world is not defined. Void function with parameters. Figure 2 shows a source code where a void function print sum is defined with two parameters. two integers a and b. Notice that within the print_sum function, we simply display a text stating that we are adding the two integers in the parameters. We called our print_sum function within the main function and we passed the values 91 for a parameter a and 23 for parameter b. In function with parameter. Figure 3 shows a source code where an int function sum is defined with two parameters, two integers a and b. This time, we added a return type of int, hence the function must return an integer value back to wherever it is called. The only statement within the sum function is a return statement which returns the sum between the two integer parameters. In addition, inside the main function, we called our sum function as a supplement to our cout string. Hence, we display right away the value returned by the sum functions. In function without parameter. Figure 4 shows a source code where an int function getFavoriteNumber is defined with no parameter. The function simply returns a constant back to whatever called it. In this case, it was called within the main function. However, in this case, the value returned by the getFavoriteNumber function is stored to an integer n inside the main function. Okay, that's it, and thank you for listening to my presentation.